Probability is the language of uncertainty. It helps us understand and quantify the likelihood of events. From predicting the weather to making financial decisions, probability plays a crucial role in our lives. Understanding probability allows us to make informed choices in the face of the unknown. We often encounter situations where we need to assess the probability of something happening. What are the chances of winning the lottery? How likely is it to rain tomorrow? These questions involve estimating probabilities. Probability provides a framework for reasoning about uncertain events. It helps us weigh the likelihood of different outcomes and make decisions accordingly. Whether we realize it or not, probability shapes our understanding of the world around us. Classical probability, also known as frequentist probability, is the most common approach to understanding probability. It defines probability as the long-run frequency of an event occurring. Imagine flipping a fair coin many times. Classical probability assumes that each coin flip has an equal chance of landing on heads or tails. As we flip the coin more and more times, we expect the ratio of heads to tails to approach 1-to-1. This long-run frequency is the classical probability of getting heads or tails. Classical probability works well for events with well-defined outcomes and a large number of trials. However, it faces limitations when dealing with events that are not repeatable or have limited historical data. Bayesian probability offers a different perspective on probability. It views probability as a measure of our belief in an event occurring, given the available evidence. In Bayesian thinking, we start with a prior belief and update it as we gather new information. Imagine you believe there is a 30% chance of rain tomorrow based on the general climate. This is your prior probability. Now you check a weather app and see a forecast of 70% rain. This new information updates your belief, increasing the probability of rain in your mind. Bayesian probability allows us to incorporate prior knowledge and update our beliefs as we acquire new data. It provides a powerful framework for learning from experience and making decisions in dynamic environments. Bayesian probability finds applications in various fields. In medicine, it helps diagnose diseases based on symptoms and test results. By combining prior knowledge of disease prevalence with patient-specific information, Bayesian analysis assists doctors in making accurate diagnoses. Weather forecasting relies heavily on Bayesian probability. Meteorologists use complex models that incorporate historical weather patterns, current atmospheric conditions, and new data from satellites and weather stations. These models constantly update their predictions as new information becomes available. Machine learning, a rapidly growing field in computer science, utilizes Bayesian probability for various tasks. From spam filtering to image recognition, Bayesian algorithms enable machines to learn from data and make predictions based on patterns and probabilities.